Hello students, I am Mousumi Moitra from Techno India Group Public School Shiliguri. I am here to teach mathematics of class 12, chapter 3 matrices, and on that elementary operations on matrices I am discussing today. So for that, first you have to know equivalent matrices. Two matrices A and B are said to be equivalent if one is obtained from the other by one or more elementary operations, and we write that A is equivalent to B. Now you have to know few properties of these operations. The first one, here I am explaining row operation. That is, for the sums, sums we have to use either row operations or we have to go for the column operations. Here interchange of ith and jth row is denoted by Ri is changing as Rj. One matrix is given here. Here we are applying row 2 and row 3 is interchanging. So check the last matrix, but the both matrices become same only, is remaining the same only after changing the row 2 and row 3 also. Now we will discuss another property. The multiplication of the elements of a row by a non-zero number k, that is, suppose each element of ith row of a given matrix is multiplied by a non-zero number k, and we are denoting it as Ri is changing as k into Ri. So here another matrix is given. We are applying here R2, that is row 2 is changing as 4 into row 2. So each element of second row we have to multiply with 4. So 4 into root 3. Minus 4 5s are minus 20. 4 6 are 24. So other row 1 and row 3 will remain same. Next is multiplying each element of a row by a non-zero number and then adding them to the corresponding element of another row. So Ri is changing as Ri plus k into Rj. Same thing here, applying one matrix given and applying that R1 is changing as R1 plus twice R2. So here 2 plus 2 into 7. 7 2s are 14 plus 2, 16. Row 1 is changing like this. Then minus 1 plus 2 6 are 12, that is 11. 5 plus 2 3s are 6, 11. So row 1 only is changing like this. Elementary column operations. Now this is also same like row operations. Now this is for column. The properties are almost same. That is, interchanging of any two columns, Ci and Cj is interchanging. That is, column I and column j is interchanging. Now any column, each element, if it is multiplied by a non-zero number k, that is Ci is changing as k into Ci. Then multiplying each element of a column by a non-zero number and then adding to the another corresponding elements of another column, that is Ci is changing like this. Now invertible matrix. A square matrix A of order n is said to be invertible if there exists a square matrix of order n such that AB is equal to BA is equal to I. Then also B is called the inverse of A, and we denote it as A inverse is equal to B. So one example you can understand better. A and B, two matrices are given. First we have to find out AB by matrix multiplication method. So first row first column multiplication, that is 3 2s are 6 minus 5 1 into minus 1 is minus 5. First row second element is 3 minus 5, 3 into minus 5 minus 15. Plus 5 into 3 is 15. So this become an identity matrix 1 0 0 1, that is equal to I written. Same way BA is equal to, also we have find out, and lastly we have got that this is also an identity matrix, that is denoting it as I. So AB is equal to BA we can write, and that is equal to I. Hence we can find out A inverse is equal to B. This type of sums are coming, that is find inverse of 2 by 2 matrix by elementary operations. Generally it's not mentioned it is row or column, so you can use either row or column. So here one matrix A is given, we can write it in the form of as the property A is equal to I into A, where I is an identity matrix. Using this property we can write that A means here 1 3 2 7, that matrix is equal to I means identity matrix 1 0 0 1, that is of 2 by 2 matrix also, and into A. So our aim is we have to convert this left hand side matrix as an identity matrix. That means 1 0 0 1 we have to convert it. To convert this matrix, left hand side matrix, into an identity matrix, which property we have to use? The same properties we have to use in right hand side matrix also, identity matrix also. So first thing is we have to get first row first element 1. It is already there, so no need to do anything for that element. Now come on to the second row first element. It is 2 there, so for that now our aim is to make it 0. So for that what we can do, see, row 2 we can change as row 2 minus 2 into R1. What is there in the row 2? 2 minus row 1, what is there? 1. So 2 into 1, 2 minus 2 becomes 0. So the same property you have to use for the second row second element also. 7 minus 3 into 2, that is 1. Second, same operation for the right hand side also. 0 minus 2 into 1, it is minus 2. 1 minus 2 into 0, it is 1 only. Now go for the next step. Next step, what is there? Already we have got first row first element is 1, but it's there left. First row second element we have to get 0 here. So how to get 0 here? We have applied here. Row 1 is changing as row 1 minus thrice R2. So what is there in row 1? 1. Okay. First element minus 0 into 3, that is 1 only. Then first row second element 3 minus 1 into 3, that is 3 minus 3, 0. So the same thing we have to do, go for the right hand side also. So this way we can get the inverse of any given matrix. So go through all these things. Thank you very much.